Hello there, my name is Peter Arnold II, and I discovered the cure for baldness. And also, I discovered time travel, which is today what we're talking about. Today we're going to travel on time to learn more about the history of the atomic model. This here is my first time machine. As you can see, I can select the time, the destined time, and we can go. Okay, so my time machine is connected to this car, which is going to go 88 miles per hour to travel back to time. Kids, don't try this at home. I'm here at ancient Greece, where around 400 before Christ, Democritus created the first idea of an atom. Oh, here he is. I'm gonna talk to him. Hello there. Oh, who are you? Hello, I'm from the future, and I'm really a fan of yours.
Oh, thank you. Why?
Because you created the first atomic model.
Yes. I've created the first atomic theory.
How did you get the idea I wanted to do?
I was helped by my mentor, Lysippus. My idea is that matter is composed by tiny, indivisible hard spheres.
Oh, would you like to come with me in an adventure to learn what happened to the atom after you invented the idea?
Well, of course I would like. I always dreamed about the future. Let's go.
Okay, nice, let's go. Democritus, now we're in the 1700s. Meet Lavoisier.
Pleasure meeting you, Lavoisier. I don't know you, but okay.
Lavoisier over here is one of the many scientists who further explained your theory. He was a French noble, chemist and philosopher who also became known as the father of modern chemistry.
Oh, bonjour, mon ami. Oui. I am called the father of chemistry because I've created the law of conservation of matter and also discovered hydrogen and oxygen. I also discovered the relationship between the combustion in oxygen and helped create the metric system. I also made a list with many elements, and I was a pioneer on that.
He was also decapitated, but don't tell him that.
C'est quoi ça? I will die in guillotine.
Oh, I said nothing, don't worry.
Yes, you said that, I heard.
Bye.
Hey, come back. Hey.
So now we're at 1803. Democritus. This is John Dalton. He is an English chemist and physicist, and his ideas were pretty similar to Democritus. So, hello, John. So long time no see, right?
Hello, Peter. Yes. I'm also famous for my research in color blindness. Did you know that? And I'm the first one to introduce the atomic theory to chemistry, and I study several chemical reactions. I also used the laws of conservation of mass, constant composition in multiple proportions to find the first evidence of the atom's existence. And my atomic model is that the atom is a hard sphere and indivisible, pretty similar to your friend Democritus. Good meeting you, Democritus.
Well, after that also came the British physicist called J.J. Thomson, who discovered the electron. What he did was, he used the cathode ray tubes in his experiments to discover that the atom is actually divisible. His model was that the atom was like a plum pudding, where most of the structure was soft and positively charged, and there were smaller particles that were negatively charged, and these particles were the electrons. Now we are at 1911, here with Ernest Rutherford, a chemist from New Zealand, who used the Goldfield experiment to discover the nucleus. Hello. Hi lads, I'm Rutherford, and
my model is much different from Thomson's. Because through my gold foil experiment, I discovered that the atom possesses a nucleus, which is dense, positive, and much smaller than the actual atom. I also discovered that the electrons are outside the nucleus, different from the Thomson model.
Who are you? Democritus?
I'm such a fan. Nice meeting you.
Well, I would never imagine that. It's really interesting. Pleasure meeting you.
Only 2 years later, 1913, Danish physicist Niels Bohr, and also Nobel Prize winner, he created a new model. Hello Bohr, what can you tell us about your model?
Oh, hello. I'm Niels Bohr, and I developed the theory that the electrons orbit the nucleus the same way that the planets orbit the sun, and that these orbits are called shells or levels, with fixed shapes and energies. But the electrons, they can go from one level to another. Now we're at 1926, where over here, Erwin Schrödinger, I don't know how to say his name, he created a quantum model. Schrödinger, where's Heisenberg? And what happened to your cat? I really liked him. What can you tell us about the quantum model?
Oh no, he asking too many questions about my cat.
Hallo, ich bin Herr Schrödinger. Oh, Heisenberg is not here. He is somewhere, I don't know. But I can explain what he did. He created the certainty principle that said that electrons don't have fixed orbits like Niels Bohr proposed, and that it is also impossible to determine the exact position of the electron. But myself, I used this experiment called the double slit experiment to further develop the quantum model. I discovered that the electrons, they have a dual nature of particles and waves. And I made an equation to represent this with all the possible locations of the electrons outside the atom. These locations are called orbitals, and these orbitals are represented.
Very nice meeting you again. My best regards to your cat, if you ever find him again. Bye.
As Wiedersehen, tschüss.
Well, Democritus, it's crazy how the atomic model evolved over not years, but actually centuries, right? Well, it was a pleasure meeting you. I hope we will meet again. Yes, Peter, it was very pleasure to meet you. I hope you meet again also. It's really crazy. I never imagined that I was wrong. And it's crazy to think that everyone was a little bit wrong, but everyone helped each other. It's a nice story. Thank you for everything. Bye.
Well, thank you for watching, and I hope you liked our adventure through space and time.